Hello, my name is Joshua Stevenson, and this is my video demonstration of the design and implementation of an automated framework for extracting and analysing browser artifacts from private browsing sessions. So, the aim and objectives for this project were to design, create, and test an automated forensics tool that will be used for the capturing and analysis of browser artifacts generated from private browsing sessions on a computer. So extract, parse, and report. And then each of these modules will be able to be worked on or updated differently in the future, making it more viable for future work. Implement a prototype of this tool that's capable of capturing the artifacts. Just showing them off. Analyze the recovered artifacts. So once it's actually, as I said, show off the artifacts, show the data that's been recovered, and then evaluate the limitations of the tool, its accuracy, performance compared to a manual analysis. So, to test this tool, so this tool's already been created, there is a E01 file that was created from a VMDK virtual machine, which itself is a Windows 10 Pro virtual machine created with VMware Workstation 17. 3 browsers were used to generate a small number of artifacts on the machine, and those were Microsoft Edge, Google Chrome, and Opera. So, for person 1, so there was 2 users created on this virtual machine. Chrome was installed, Opera was installed in private mode, Fish Swimming was searched on Opera, not in private, Green Trees was searched in private, Red Penguin was searched on Chrome in not private, and T-Rex was searched on Chrome in private mode. And then for person 2, same again, Chrome and Opera were installed. A site was visited with Opera, as well as a YouTube site the YouTube main site being visited, at which point a video was watched whilst in private mode. There's some searches conducted on Chrome, and then some more searches on Edge, as well as the Grammarly extension being installed on the browser. So, all the code used for this project is available on my GitHub, so kanedarkley/dissertation, on which there is a README that explains how to use the tool and how to set it up on your own machine. So, if I now quickly switch over to Encase before we demonstrate. So, in Encase, this is the VMDK file that in E01 was created, and in Encase, if we wanted to view the browser artifacts, we would have to go into the artifact view and then select on the internet record. So you've got all the different browsers here, you've got the history, typed URLs, and then as you can see, it is stored as text here, which is not always the easiest to read. And then if I were to go into Chrome as well, much bigger. So the information is absolutely there for a forensic investigator, but it's not always the easiest to find and correlate with each other, and there's absolutely no indication if any artifacts were created from a private browsing session. So if I now go over to the tool, so this is what it looks like, the forensic artifact extractor. So first you select and process the E01 file, and then you're able to view the artifacts on it. So if I just choose the E01 file that was created from Encase, so that would be this one here. So then it, and it takes a couple of seconds to mount it. So there you are at the bottom there. It has now been mounted. If I go into my file directory here, you can see the new local disk that's been mounted. So this is my initial one, and then this was created from the E01 file. And if I go back to the tool again, so make sure you've got the E0 mounted before continuing, as I've just done, as it then needs to be mounted by Arsenal Image Mounter. And this is because a Python program can't natively process E01 files, so it mounts it and then treats it as a regular file directory to extract it. So we select the artifact outputs to extract the folder to, and then I'm going to start a timer alongside this just to demonstrate the time taken for it to extract the artifacts. This does take some time, so I'm either going to skip over this or make a time lapse. Okay, and there we go, that's that completed. So I can now stop the timer That took about 6.5 minutes, so typically it can be a bit quicker than this when it's the only program running, but as of right now I've got screen recording software and other applications open, so it has taken a bit longer than usual. So now that that process is completed, we can go then and view the artifact. So you can see this extraction here. So it's got the date of the 3rd of May 2026, and then the time of the extraction as well. So it automatically gives them a time date stamp so that they can be differentiated between. So as you can see here, we've got a users and then the browser and then the different tables. But before that, I am going to verify the forensic integrity. So here we are. As you can see, the MD5 SHA-1 and SHA-256 hash values of the extracted data are all the same, so they were calculated before the extraction and they are then recalculated afterwards to make sure that no data has changed and it's still forensically viable, so nothing's changed, it's the same evidence. So, starters, if I were to go to the keyword search terms, so person 1 on Chrome, search for red penguin, that tracks, that's what's in the testing data. If I were to go to Edge and then look at the same ones here, so keyword search terms, yep, the Google Chrome install, so the private one isn't shown because private search terms are all saved within the RAM of a computer, and as such, the second the browser is closed, that's gone. So there are some private artifacts that can be recovered from a live extraction, but that is not possible in the real world during an investigation because the first act that's taken is the machine's turned off, so those artifacts are gone. However, if we are to go to person 2, switch to Edge, and oh, what's this? We have a potential incognito browsing session because there is a download detected in here. So here we are, we've got a download of a file. However, there is no search terms to go along with this. So we can see that OperaGX was installed. Where's Chrome? Where's the Chrome installation? So, as you can see in the others, none of the others have been flagged. So you've got Chrome, Edge, Opera, and all of these have the same tables, so keyword search terms. It's essentially the history database is what we have here. So we have the URLs, visits, downloads, segments. Absolutely everything's been extracted. A lot of these are fairly empty though, as not a lot of searches were made. So like download slice is empty, but it is all extracted. All the data is there. So another thing that we can do is we can then click this button to show the flagged artifacts, and this will list all of the potential browsing sessions that have been detected by the computer. So here we are, we've got the opera setup.exe downloaded file, but we have the missing artifacts that should be with it, so where are they? And hence that's been flagged up as a quiet window, so there's a gap of 3 hours and 8 minutes. So in theory, that was a private browsing session. So the others haven't been detected as no artifacts were created, but if a user were to go and download some data or make bookmarks, those artifacts will be permanent and will not be deleted once the session ends. So therefore, those will be flagged up and go, oh, where's the search terms for this? Why is there no other information? This is most likely a private artifact, and it does this for all other artifacts on the extracted device. However, in this case, only one of them's been detected, and it sorts them by the users and the browsers. So everything's all nicely organized, whereas in EnCase, if we go back to that, you have to search through these files to work out which artifacts belong to which user. There's no straight up indication in this file directory at all. So in that aspect, this is much easier to see and look through the data that's been extracted. So finally, if we go back to the presentation and carry on. So results, an extraction time of around 5 minutes for the artifacts that were prepared for this testing data. So not a massive amount of time for the data it's extracted, and it is I believe 1 to 2 gigabytes in size, so it's a substantial amount of data that gets extracted. We've got the simple and easy to use database viewer, which I'd argue, is much nicer to look at and use than the one in Encase for looking at the artifact. The forensics integrity is verified, so the results of this tool can be used within a forensics investigation report. As no data's changed there, it can be added to a chain of custody. Everything's solid, there's no room for doubt within the information. And if the files are modified, then the hash values won't be the same, can't be used, it's been corrupted. And then highlights the detected private browser artifacts. So if it suspects there to be a private browsing session, that's highlighted. And typically, private sessions will have data that a user typically doesn't want people to find out about, so they might be of great interest to an investigator. So having a section where those are all listed and say, oh, there's this one, this one, this one, and this one, will save forensic investigators a lot of time when it comes to looking through it and just making sure that they've got all the information they need. It helps highlight information that could be of interest to them. So, limitations of this tool. The big one is that it's designed for the Windows OS only, so it can't deal with Linux machines being input into it. So, for the reason of that is the E01 files are generated from Windows machines, is what it processes, and the Linux machines use a different way of processing things, and also this runs on Windows, so the way in which it mounts the E01 files is designed for a Windows machine. Second limitation, it does take some time to extract artifacts, so the bigger the data that it's being given, the longer it's going to take to extract it all, because it is, at the end of the day, a lot of data. So the private mode detection provides indicators, not proof of a private browsing session, as the user may have gone through and deleted some artifacts. So, for example, if they've gone and wiped their search history, but the downloads still remain, it will also show up as a potential private browsing session. So it's not undeniable proof that it is, but it's as much proof as is able to be gotten, basically. And then next, so not all private browsing artifacts generate any artifacts. Actions generate artifacts, sorry. So, for example, in the testing data, there were some search terms Googled for within the private sessions of the browsers. There's no evidence of them at all in the extraction, unfortunately, as, like I've said, it's stored in the RAM, which is volatile memory. We are only able to extract artifacts from the non-volatile memory because of the state of how E01 files are generated. And then finally, the artifact viewer is not a full database viewer. It's only the first 100 rows in each of the tables. So it's a triage view, so it's limited. So if an investigator does want to view the full table, a new method of doing this would have to be implemented into the tool. And then finally, future work. So obviously, Linux compatibility or just other operating system compatibility. The tool would most likely still run on a Windows machine, but it would have a method of interpreting the artifacts from a Linux machine. So then all the artifacts can still be extracted. User capability of flagging artifacts. So there's a function within Encase where the user can basically click on a file and put a tag on it, or like a note, a bullet point, some form of mark, and from them they can then view all of these marked artifacts, or files rather, all in the one section, so it helps them to link them together. Having something like this in this tool would be very helpful if they're trying to track a series of possible related searches that haven't been flagged up from private browsing or are just normal browsing sessions that seem suspicious. Thirdly is the compression of extracted data. As I said, the data is about 2 gigabytes, so if you're doing multiple extractions, that is going to take up a lot of storage space. So either just compressing the extracted data to a zip file, or just some way of compressing the size of it so it's not as big and not taking up as much space in storage. And then finally would be a method to export the detected private sessions as a report. So there's this session here, there's this session there. Just export it to a text file or something similar to save an investigator time during an investigation. It's something that they could then reference. So, oh, there was this, there was this, there was this. It just saving them time, which is the overall aim of this tool. And